Hey guys, I hope everybody out there is staying healthy and taking care of themselves. So it's been a while since we've been in math class. So I'm going to do a quick review of what we were talking about, looking at polynomials. And then I will continue where we left off, which was multiplying polynomials. So a quick review of what a polynomial is. And so remember, a polynomial is essentially anything with a whole number degree. A whole number degree. And so that's all of these examples below here, right? You could have a 3 as an exponent. You could have root 5 times by x cubed, any whole number as a degree. Things that aren't considered polynomials are things like over here where I have a negative degree, or which is when the exponent is on the denominator. Also, if it's not a whole number, so if your exponent was, like 2.5 or 3/5, those don't count as polynomials. Some other things we have to know about polynomials are looking at a really brief or basic polynomial here, ax squared plus bx plus c. We have to be able to identify the constant, which is the term without the variable. You have to be able to identify the degree, which is the highest exponent in that polynomial, and the leading coefficient, which is the coefficient attached to the term with the highest degree. And then we did a little bit of a review on how to add and subtract polynomials. That's a review from grade 9, so I'm hoping I don't have to spend too much time going through that. And then we looked at some different strategies for multiplying binomials and monomials. So I want to do a quick review of those two strategies, and then we'll look into where we left off, which is multiplying larger polynomials. So the first question here is just a monomial being multiplied by a polynomial. And for this type of basic question, I can solve with distributive property. And distributive property is saying everything outside of the brackets gets multiplied to everything inside of the brackets. So if I want to rewrite what's happening here, this is negative 3x times 4x squared. That's this first multiplication. Now here's the second one, negative 3x times negative 12. So negative 3x times negative 12. And once I've multiplied that out, now I would just simplify. So negative 3 times 4 is negative 12. And x times x squared is, remember, you have to take your polynomial or your exponents and add those together because we're multiplying. So that would be x to the power of 3, because 1 plus 2 is 3. Then I would do the same thing for the next part. So negative 3 times 12 is going to give me a positive 36. And x is just multiplied by itself, so x. And so there is that polynomial multiplied out. Now, remember, I don't necessarily want you to put this step here every time. That's just to kind of remember what's happening here. If you can see and multiply out and go straight to this step, that's obviously fine with me. The next one is looking at binomial multiplication. So we looked at binomial multiplication and looked at a few different strategies. We could use algebra tiles, we could use grid, and we could use distributive property. And I'll take a quick review on all of those. So first one is algebra tiles. So I had said in class, algebra tiles is only useful for kind of a restricted amount of questions. We can't use algebra tiles if there are multiple variables. We can't use algebra tiles if we have a degree higher than 2. And once you have really large numbers, you don't want to use algebra tiles anyway. This particular example, we can use algebra tiles to solve. So remember, we take our axes or our grid and we can spread that out. The other thing we have to remember when I'm solving this question is 3x minus 2 is squared. That's like saying there are 2 3x minus 2s. And then I would multiply them out. Do not distribute this in. That is the wrong thing to do. You can only do that exponent law if it is a monomial. And right now we have a binomial, so that exponent law doesn't hold true in this example. So if I'm going to solve this example using algebra tiles, I have to split these up. So 3x, let's say white is positive, so 1, 2, 3x, and then minus 2, so 1, 2. And then 3x here, so 1, 2, 3, and then minus 2, so 1, 2. Remember, if you're using algebra tiles, you have to make sure that you're drawing them like in a proportional shape. Otherwise, when we start these little dashed lines here that kind of give us a better idea as to what shape goes where, I can't see if everything doesn't kind of make sense in terms of proportion. Mine's obviously not perfectly proportioned, but it's going to give me a decent idea of what's going to happen here. Okay. Now I can just take a look and say, well, what's going to fit in each of these? Well, right here, it looks like a big square, big square, big square. And that makes sense because this is x times x is x squared. X times x is x squared. And I continue. They were all positive, so all of those are going to remain positive. Next thing I have to do is take the x and multiply it by a -1. So this is all rectangles over here, but they are going to be shaded in because these are all x's being times by a negative number. So all of these here would end up being negative. Okay, and same thing down here. I have x being times by -1s. So all of the rectangles down here are going to be negative. Okay. And the last portion that I have to multiply out here is, you can tell we got to have 4 little squares here. But those are negative times negative, so those actually remain as positive numbers. So I could summarize that once I've multiplied using my algebra tiles to say there are 9x squareds, there are a -12 x's plus 4. And so that's using algebra tiles. Let's go use a similar strategy, but now we're using an algebraic representation. So let's go multiply this out using a grid. So I do the same thing and use an axis, but now I'm going to split up each term in my binomial. So if I put 3x minus 2 here and 3x minus 2 here, I'm going to split the binomial up into 3x minus 2, and the other side, same thing, 3x minus 2. Now, once I put my partitions here, I'm really just multiplying each term by every other term. So when I look at this square right here, this is like saying, well, what's 3x times 3x? And we should know that that's 9x squared. And then same thing in the other subsequent boxes. So 3x times -2 is -6x. In this one, 3x times -2 is -6x. And -2 times -2 is 4. Then I should summarize those the same way that I did over here and hopefully get the same answer because I'm multiplying the same question, is 9x squared. And remember, if you're using grid, usually your like terms are on the diagonal, so you can combine them. So that's -12x and plus 4. And regardless of which way I do it, I'm going to get the exact same answer. Let's do one more and show you like distributive property or FOIL for a binomial, and then we will continue into where we would have left off, which is larger polynomial multiplication. So one more question here. Let's say I gave you 3x minus 5 and x plus 1, and I want you to multiply out that binomial. The other strategy we can use is distributive property. Distributive property. Or what some people might want to say is FOIL. And again, distributive property is just saying that everything in one set of brackets needs to get multiplied to everything in the other set of brackets. So in this example, what's going to happen is I take the 3x and I would multiply it to everything in the second set of brackets, and the -5 and multiply it to everything in the second set of brackets. So when I do that, I can just follow this out. So 3x times x is 3x squared. That's this one. 3x times 1 is plus 3x. -5 times x is -5x. And -5 times 1 is a -5. So once I've multiplied everything out, all I need to do to have my final answer would just be to combine my like terms. So 3x squared minus 2x minus 5. If you are using FOIL, talked about it briefly, it's a strategy you can use to multiply out binomials. It doesn't apply to anything else other than binomial multiplication because it stands for the first terms in the binomials being multiplied together. So first, the outside terms, the inside terms, and last. And it's just a mnemonic device to make sure that you're using distributive property properly with binomials. Okay. So with that being reviewed, let's go into where we would have left off. So where we would have left off is multiplying polynomials. So we're taking larger polynomials and multiplying them together. And so here's an example. It says solve using the distributive property, then state the degree, leading coefficient, and constant once this has been multiplied out. I'm just going to rewrite this here for myself. So y minus 3, y squared minus 3y plus 1. Okay. So the distributive property says everything in one set of brackets needs to get multiplied to everything in the next. So what that means is I'd have to multiply 1, 2, 3 times with this y, and I do the same thing to the negative 3. So 1, 2, 3 times. Now that I know where I'm multiplying, I just need to go ahead and do that. So y times y squared is going to give me y cubed. Y times negative 3 is going to give me a negative 3y squared. Y times 1 is going to give me a plus 1y. That's the first thing being multiplied to everything in the other set of brackets. Now I'll take my negative 3 and do the same thing. So negative 3 times y squared is negative 3y squared. Negative 3 times negative 3y is going to give me a positive 9y. And negative 3 times 1 is a negative 3. Once I have for sure multiplied everything out, all I need to do is combine my like terms. So y cubed, that's the only y cubed, so I'll bring that down. I have a negative 3y squared and another negative 3y squared, so I can combine those like terms to give me negative 6y squared. I have a plus 1y and a plus 9y, so that's a plus 10y, and the negative 3 is just my last term, so negative 3. So once I've simplified the multiplication out of that binomial by the trinomial, I can answer the rest of this question. They wanted to know what's the degree, what's the leading coefficient, and what's the constant. So the degree is the highest degree in the polynomial. Well, my highest degree here is going to be a 3. The leading coefficient is the coefficient attached to the term with the highest degree variable. So if we remember, there would be an invisible 1 right there. And the constant is the term without the variable. And so the constant for this is negative 3. When you're stating your leading coefficient or your constant, you need to make sure that you bring your negative with you if that's what's there. Okay, so that's solving using distributive property. You cannot, for anything larger than a binomial being multiplied by a binomial, so like this example, because this is a binomial by a trinomial, you cannot use FOIL. Okay, FOIL will not work in this circumstance because FOIL only tells you to multiply out 4 times. Here, we had to multiply out 6 times. So FOIL is kind of limited in its application. All right, let's look at another one. So it says solve using grid. So grid, exact same strategy as we did before. I'm going to use the grid. So let's say I'm going to put 2x plus 7 over here. So I would just break that up into a 2x and a positive 7. And I'll break this up because I'm going to put x squared minus x plus 4 here. So I'll break that up into an x squared minus x and a positive 4. Now, when I use a grid, the nice part about using a grid is it tells me exactly how many times I need to multiply out. I have to multiply out 6 times here, which is what I did before with the distributive property. And so I'm multiplying, and all I will do is take each term and multiply. So this is 2x times x squared. That's what's happening when I kind of follow my rows there. So that's going to be 2x cubed. Next one, if I follow my rows, so it's 2x times negative x is going to give me a negative 2x squared. In this one, it would be 2x times 4, so that's 8x. X squared times 7. X squared times 7 is going to give me a 7x squared. 7 times negative x is going to give me a negative 7x. And 7 times 4 is going to give me 28. Once I've multiplied out, it's similar as to what we had to do previously, which is just combine my like terms. Again, on a grid, your like terms should be diagonally across from each other, but that's not always going to be the case, especially if you have multiple variables in there. So I could technically write this all out. It's 2x cubed plus 7x squared minus 2x squared minus 7x plus 8x plus 28. If you can just skip to the simplification, that's fine too with me. And so what I would do, there's only one 2x cubed. I'd combine these. So 7x squared minus 2x squared is going to give me a plus 5x squared. Negative 7x and a positive 8 is going to give me a plus 1x. And the last term is plus 28. That's just my constant. And so when I multiply out that binomial and trinomial, that's my resulting answer. So really the only strategies you can use when you're multiplying larger polynomials is distributive property and grid. I can't use algebra tiles because I have terms that are in the third degree and it's hard for me to draw anything other than 2-dimension. Also, these might have multiple variables. It's not going to work. For algebra tiles, and FOIL doesn't work because it's limited. I already said that. Okay, last example for today is looking at finding a volume of some polynomial where we don't know the exact side lengths. Now, if I had a regular box, and I just say, here's this cube, find the volume of this. Let's say this is 7, this is 2, and this is 4. Well, to find the volume of a rectangular prism, I would just go volume is equal to length times width times height. So to find the volume of this rectangular prism, I would just go 7 times 2 times 4. And my volume would equal whatever. So the same thing applies when it's polynomials. I'm still going to take the volume and go length times width times height. Now it doesn't matter which side length here I delegate to length, width, height, as long as I don't repeat myself when I put them into substituting into the volume. So volume is equal to the length times the width times the height. And so I'm going to go figure out what that polynomial is. So the volume is equal to the length, which is 3x plus 2, times 2x minus 3, because that's the width, times the height, which is x plus 1. So really, I'm just taking each of those dimensions, and I'm going to multiply them all together. Now, I can't multiply this out all at once. I need to take this step by step. So I'm essentially just going to ignore that even exists and multiply out these binomials. Okay, so multiply, oh, that's really ugly. Multiply out 2 binomials first, because a lot of people will just try and do it all at once, and you can't do it. 2 binomials first. So we'll just multiply out these guys right here. Now you could use a grid, you could use algebra tiles at this point. I choose to personally use distributive property just because then I don't have to put it in a grid and then put it back into my equation and then use a grid again. So I'll multiply each term by every other term for my 2 binomials, ignoring that term at the end for now. So 3x times 2x is 6x squared. 3x times negative 3 is going to give me a negative 9x. 2x times 2 is going to give me a plus 4x. And 2 times negative 3 gives me a negative 6. And so I will simplify that to give me 6x squared minus 5x. That's what this would combine to be, minus 6. So that's the first set of binomials multiplied out. This x plus 1 I haven't really touched. I'm just going to keep bringing it down. So x plus 1 and x plus 1. Now, that's not the answer for my volume because they probably, or most likely, wanted it in as a simplified multiplied out polynomial. So now I have a question like we just had where I have a trinomial being multiplied by a binomial. And so I would take each term here and multiply it to everything in the other set of brackets. So let's follow that. X times -6 is a -6x. X times -5 is a -5x squared. X times 6x squared is a positive 6x cubed. And I'll do the same thing with the 1 multiplying it to everything in the trinomial. So 1 times -6 is a -6. 1 times -5x is a -5x. And 1 times 6x squared is a positive 6x squared. Once I have everything multiplied out, then it's just a matter of simplifying my like terms. So my volume, and anytime we're answering like with a polynomial, we start with the highest degree to the lowest degree. So I would start off with the 6x cubed. Then I can combine -5x squared and a positive 6x, so a positive 1x squared. -6x and a -5x could combine together to give me a -11x, and this constant is just by itself, so -6. So that would be the volume of that cube. Okay. I will post this video, and in the comment section, check out the corresponding homework that I would like you to take a look at. All right. Thank you.